Hello everyone. Today we are going to discuss on current electricity. This question I have taken from NCERT textbook of class 10. First, let's see the question. How much current will an electric bulb draw from a 220 volt source if resistance offered by the bulb filament is 1200 ohms? How much current will an electric heater coil will draw from a 220 volt source if the resistance of the heater is 100 ohms? Here in this question we have been given two equipment. One electric bulb which has resistance of 1200 ohms is kept across 220 volt source, and the second one is the electric heater which has the resistance of 100 ohms kept across 220 volt source. So we will discuss the dependence of the current on resistance when the voltage is kept constant. So let's first discuss start our discussion from Ohm's law. Ohm's law states that the voltage across or the potential difference across the ends of a conductor, the potential difference across ends of a conductor is directly proportional to current flowing through it. Given the temperature is kept constant. Throughout the period. So let us assume a circuit here. So here I have a circuit. In the circuit I am keeping an ammeter in order to measure the current passing through the conductor. I will keep between X and Y. So this is X and Y. And I have a source here, battery source. Let us assume that this battery source is variable. That is, it can change the current passing through the circuit. Okay, so current will flow. Let us place one switch also here, and let me keep a conductor in between X and Y. So I am also interested in measuring the voltage across X and Y. So for that I need a voltmeter. So now the current will pass through the circuit, right? The circuit is complete. So the current would pass through the conductor. See here, the current will pass through the ammeter. The same current is going to pass through the conductor. Okay, no current will pass through the voltmeter. Okay, we'll assume that our voltmeter is ideal voltmeter. Our voltmeter is ideal voltmeter, where the current entering to the voltmeter is 0. In generally, a minimal amount of current passes through the voltmeter. So in this case, let us consider an ideal voltmeter. So current passing through the voltmeter is 0. Hence, all the current passes through our conductor between X and Y. So all the current is passing through current X and Y. So I will get the reading, current reading from ammeter, potential difference reading from voltmeter. Now if I keep on increasing the current, remember this is my variable source, I can increase the current coming into entering the circuit, passing through the conductor. So if I keep on increasing the current pass in the circuit, so what I will find? I'll find that the potential difference between X and Y is also increasing. So that means this potential difference which we have, V is, I'm denoting it by V. V is proportional to I. Hence we also write this as V is equal to Ri, where R is proportionality constant. And R is also called as resistance. Every substance in this universe has the ability to resist the flow of current through it, or resist the flow of charge through it. So if different materials will have different ability to resist it. Some will have more, some will have less. So this conductor will also have what? Resistance. And don't forget, throughout this activity or experiment we are keeping the temperature constant. So V is equal to Ri. V is equal to Ri is what we are going to get. Now remember in this question, when voltage is kept constant, when the voltage source is kept constant, 220 volts, right? Voltage source is kept constant. So who maintains this voltage across the conductor? Who maintains the voltage across the conductor? My voltage source, right? The potential difference in the circuit is maintained by the potential across the circuit is maintained by the source. So when I'm keeping the voltage constant, across my conductor, so let me make it a constant source then. So this is my constant source. This is my constant source now. So this voltage is constant now. So the same voltage is created across X and Y. Remember, as my voltmeter is ideal, my ammeter is also ideal. That means the potential drop across the ammeter is 0. The resistance of the ammeter is so small that the potential drop across it is 0. So all the potential difference which is created by this source will be appear across my conductor. Correct? So when I keep my voltage as constant and I change my conductor between them, right? I'm keeping my voltage as constant now and I'm changing my conductor, right? So then what would happen? The product of Ri will remain constant. Or you can say that the current is inversely proportional to resistance. For example, if the resistance is more, what happens to the current? Current will be less. If the resistance becomes less, the current will be more, right? Inversely proportional. So let's see, is that applicable here in this question or not? So in the question what we have, let's take the first case. First. So in the first case what we have a bulb. Right? So electric bulb. So I am placing electric bulb here. Right? Now what source we have? 220 volt source. I have 220 volt source. So some current will flow. I'll measure it by using ammeter, and there will be some potential difference across the bulb. I'll measure it by voltmeter. What would be the potential difference across it? 220 volt. What would be the potential difference across it? 220 volt. Correct? Now, how much is my current? So from Ohm's law, V is equal to IR. So how much will be the current? So current is equal to V by R for this case. Current is equal to V by R. Right? Now let's come to this specific case. Then let me write it as I across bulb, current across bulb is equal to voltage is how much? 220 volt. Potential difference how much? 220 volt. I'll get this from here. By resistance of this, how much is the resistance? 1200 ohms. So let's do some cancellation. 0, 2 11s are 2 60s are. So how much this would be? 11 by 60. So I can write it as 1.1 by 6. So 0.1s are 50, 8s are 48, 203 and so on. So approximately it is around, let us keep up to 2 digits, 0.18 amps. So the current passing through the bulb is 0.18 amps. How much I'll see here? I'll see I is equal to 0.18 amps. Excuse me. Clear up to here? Now let's go to the second case. This is for A. This is for A. Let's go to the second case. Okay, so what is the answer we got for A? The answer is, for case A, answer is 0.18 ampere. Let's take the case for second case. So what we have in the second case, we have a heater. So let me replace the bulb with heater. Okay, let me replace it with a heater. So this is heater. So what is the current across heater? Current across heater is equal to voltage across heater. How much? Same voltage, 220 volt. So same reading will come across this voltmeter divided by what is the current passing through it. Sorry, what is the resistance of it? 100 ohms. Resistance is 100 ohms. So current is equal to 2.2 amps. Clear? If the voltage is kept constant, what did we see? If the voltage is kept constant, I is inversely proportional to R. I is inversely proportional to R. Right? So in the first case, when the resistance was at 1200, so in the first case, how much was the resistance? 1200 ohms. Current is 0.18. When the resistance is 1200 ohms, so the current is less. In the second case, when the resistance is just 100 ohms, see the current has increased 2.2. When the resistance decreases, the current increases. This is the case when voltage is equal to constant. So when the potential difference across a given conductor is kept constant, across a given terminal is kept constant, then the current is inversely proportional to the resistance. This is what we have learned today. If you have any doubts, please write it in the comment section. I'll make a video on that. Thank you.